In this Godot Engine tutorial, we are learning how to use the built-in draw function to create custom shapes for 2D user interfaces and games. While the Godot Engine has nodes that you can create sprites, polygons, particles, a bunch of other things, when you need to create something that those nodes don't provide, you can actually manually draw on the screen using the built-in draw commands. This can be useful when you want to create specific shapes or objects or a whole bunch of objects on the screen when creating a high amount of nodes would actually hurt performance or creating custom UI controls. The draw function is available in any canvas item base class node. So this includes all of the control nodes and node 2D nodes. We're going to start by creating a basic circle. First, create a new 2D scene with a node 2D parent. Next, add a new node 2D node as a child and name it circle. Add a new script to the circle node and add the following lines. The draw function is where we'll place our custom drawing logic, and this is a built-in Godot function, and by adding it to our script, we're overriding the default logic with whatever we put in there. The Q redraw function is going to be placed within our process function, and we need that to manually tell the engine to redraw every single frame. Now, the drawing logic that we put in the draw function comes from a number of built-in drawing functions for a range of purposes. I'm going to link to those in the description. But to summarize, you can draw shapes, texts, strings, primitives, polygons, a whole bunch of things, including textures, right there in your drawing function. To add our circle, go to the draw function and add the draw circle function. Within our draw circle function, we have a number of parameters that determine properties of our circle, including position, radius, color, whether or not it's filled, a width of the line if it's not, and whether we use anti-aliasing. For our test, we're going to create a solid red circle using this code. With our code in place, we can test this by running our scene, and you should see a red circle in the upper left corner of the screen. Let's make it a little bit easier to see that and move that to the middle of the screen. We're going to use our screen center, and to get that, we get the viewport size and divide that in half. Then we can plug that into the position of our draw circle function. You can add any number of commands within the draw function. So let's go ahead and add a line after we create our circle. When you run your scene, you should see a red circle and then a line going up to the 12 o'clock position. Now, because we're doing this every single frame within the process function, it also means that we can dynamically change those properties of our drawing functions to actually animate our drawings, or have them dynamically react to what the player is doing. For our test, we're going to have our line rotate around the circle like it's the hand of a clock. To do this, we need to adjust the endpoint of our draw line so that the point rotates around the center of the circle. We do that by multiplying the circle radius that we set with a cosine and sine as we create a sum of time using our delta. Each frame, time increases by our delta or the time between our frames, and then we get the sine and cosine of time to simulate the endpoint moving around the circle. And just by using a few lines of code, we've actually created a custom clock graphic that we can easily adjust its size, color, and shape. And while this example is really basic, you can use this draw function to create graphics that are very responsive to your code, opening up a lot of possibilities for UI and 2D graphics.